If you've driven down the 405 during peak hours, chances are you've seen them. Stressed, erratic drivers with little concern for the safety of others. Over the years, cars have implemented safety functions to keep drivers safe. In our project, we aim to design a safety system which detects driver stress using a neural network. So, how did it perform? In this first scene, we had a volunteer drive while not stressed. They made sure to drink water, eat a snack, and listen to lo-fi music beforehand. Our project captures the driver's heart rate, breathing rate, and galvanic skin response. In a setting with no stress, heart rate should be around 60 to 80 beats per minute, breathing rate around 10 to 18 breaths per minute, and GSR between 1 to 5 microsiemens. As you can see on the bottom left of the overlay, the driver displays these signs, and the model's predictions for stress is below 10%. This is a trend that continues throughout the trial. As you can see in the bottom graph, this model has very low predictions for stress, which means it's predicting no stress given the driver's biometrics for the majority of the drive. Now, take a look at the third graph. Red lines show moments the driver was at a stoplight. Looking at the first graph, we see heart rate is the blue line. It's hard to see, but notice how each time a stoplight is approached, heart rate fluctuates, as well as the stress confidence. This will become more apparent in the stress trial. Here, we see a driver that had multiple assignments due and was running out of time to complete them. He self-reported high levels of stress. As you can see in this video, his heart rate is above 80 beats per minute, and GSR is above 5 microsiemens. The model is frequently reporting stress with 40 to 60% confidence. Also, look at the top left of the overlay. Note the speed at which he's driving and intensity in his braking patterns. It differs from the defensive behavior shown by the first driver. Notice how quickly he's engaging in the throttle and brake at the stoplights. You can even see him crossing over stop signals in the next few seconds. It's evident he's driving rather aggressively. Looking at the graph for this trial, we can see the model predicting stress with higher confidence compared to our first trial. Yet again, we see these spikes in heart rate when approaching a traffic signal. Additionally, we can even see fluctuations in GSR at the same times. There are also sharper spikes in speed and braking intensity, all of which correlate to fluctuations in stress predictions. We've only conducted a couple trials so far, but the results look promising. There exists some correlation between driving behavior and biometrics, which, if properly mapped, can be used to develop a safety system to suggest safer actions to stressed drivers.